This is homework number 2. I want to go over with you. Again, I'm removing chapter 3 since I moved it to the next lab 3 with it as well. But let me go over some of the questions that we went over in this homework. It starts with number 2, 8, 12, and 16. This is the chapter exercise at the end of your DS Malik. So let me talk to you about the first one. It asks which are valid, and all you have to go in, if you remember in your reading, it covers valid means what? Valid in identifiers. Identifiers are what? Identifiers consist of 3 things. There are variables, constants, and functions with it. These are what we talk about is they could be name of a variable, name of a function, and name of a constant. As you recall, the rule in naming the constants and variables and functions in programming is we stick with alphas, numeric, and underscore. So no special character, such as a plus plus, this is invalid. So A is invalid. Time travel is valid, okay, with an underscore as a space, that's fine. 3 feet in a yard is invalid. You cannot start with a number. And the number 3, that's invalid. So far we got B is the only one that's valid. The next one is you can start with an underscore and alpha, underscore number. So that's valid. The next one you can do is CPP underscore assign. This is valid. Inches in 1 centimeter, as long as this is valid. So you get B, D, E, and F are valid. Monthly pay with a space in the middle, that's invalid. Jack's homework with an apostrophe is a special character, that is invalid. First pound, or some we might call hashtag nowadays, that's a special character, it's invalid. Bonus amount, $sign, no special character, that's invalid. So these are the ones that the only ones that are valid here are B, D, E, and F. All right, let me come down to number 8, to the next page. I'm going to go over here. I want you to take a look at this one because this is, a lot of you kind of missed this when I graded you on this. Is they declare integer as num1, num2, and new num, and double is x and y. Which one of the following is valid? If it's not, you tell me why. Give a state reason why. Now, the purpose of this problem is to demonstrate the equal sign to you. And one of the things I want to tell you in programming across the board is it's different the way how you think about how it happens in algebra. You can flip each side, but in programming, the right side equals the left side. Remember that. You're putting the content of the right side inside of the left side. So if num1 is an integer, okay, and you're putting 35 the right side of the equal sign into num1, so this is valid. All right, so A is valid. Take a look at this one. This is the expression of num1 minus num2. Store that into new num. Okay, let me ask you a question. Go back to num1 here, equals 35. What if I have 35.6 and num1 is an integer? What is stored in num1? Well, it's going to be 35. It's going to drop off that decimal part because num1 is an integer with it. Okay, so it has only 4 bytes. You can't fit an 8, something as a decimal inside of a 4 byte. Like you can cast up, meaning if num1 is a double and you stuck 35 into num1, it's going to be 35.0. Okay, you can cast up, but you cannot cast down. Okay, which means you can go from an 8 byte, which is a double, to you can't put an 8 byte into a 4 byte, which is an int. But you can go from a 4 byte, which is an int, to an 8 byte, which is a double. Okay, so if this was 36.9 or 36 with a decimal, and num1 is an integer, it's going to just store the integer part, which is the 3635 in that decimal with it. Okay, so A is valid in this case. B is valid. Okay, take a look at part C. Well, if you separate these out with a semicolon, and you look at num1, store that in 5, num2, you put this expression into num2, so it becomes what 2 plus 5 is stored into num2 is 7, and then you take 7 here, is num2 divided into 3 is what? It's actually 2.333, whatever it is, the decimal part, right? But num1 is an int, so it's only going to take what? The 2. So it's going to be 7 divided into 3. 3 goes into 7 2 times. Whatever the decimal part gets dropped because of num1 is an integer. Okay. There is a test question on this, so be careful with that. All right. All right. Let's look at D. So in other words, C is valid. By the way, the whole thing is A, B, C is valid. Look at this expression. What's wrong with this? Again, they're putting the expression on the left-hand side of this equation. It needs to be on the right-hand side of this equation. So new num. So this is invalid. Okay, you can't do this. In algebra, yes, it works, but not in programming. Look at this one. You're taking this expression and storing it into the 2, which is not a memory, right? Not. Look at this one. What's wrong with this one? So look at this expression. Try and store this into y. Can't do that. All expression needs to be on the right hand side, stored into one variable. Look at this one, h. What's wrong with h? Well, the problem with num2 is an integer. Mod would take you to do what as a remainder with it. So num1 mod 2.0 is going to have some decimal part, whatever it is, with it, and this is a integer, so it doesn't have, it's going to be an error. So h is invalid. Look at I. This is their static. This is a static expression. Remember in your reading, x is your expression, converts into an integer, whatever the x is. If you look at the ASCII value in the back of your book, there's an ASCII table, appendix 2, I think it is. And you look at mod 5, whatever that value is, store that into. So I don't know. I'm just gonna make up a number. Yeah. So x happens to be like 26. So I'll make that up with it. So 26 mod 5 is what? 1, right? So 1 is starting new num. So I is valid. Look at this one. I don't know what x and y is in this case with it, but it stores into x. So j is valid. Look at this expression. Everything that you do here is going to store into. So k is valid. So just to repeat, what's valid in this one? So you got A, B, C, E, I, J, K are valid. Okay, so that concludes number 8. Next one I want to talk to you about is number 12. Let's take a look at number 12 here. Again, it asks you to write the expression on these things with it. You have to be very, very careful on how you write these expressions, because these expression is basically a short snippet code with it as well. So let me talk about some of these expressions and how you write this. Remember, I hate writing in auto in Word, so I'm going to open up just a notepad. That way I don't have to deal with autocorrect in this thing. So it says int variable xy. So it's declaring your int variable. So this is number 12. So how would I answer that? Basically, it's int x comma y. You could declare this at the same time, or what you can do is go in, if you're lazy like me, or if you're in a hurry, depending on how I get paid, x is equal to 25, and y is equal to 18. Okay. B, declare initialize the variable of the integer variable temp to 10, so you could do int temp equal to 10 semicolon, and you could do char, which is a character, ch is equal, you got to your apostrophe with it and a semicolon. Okay. C, update the variable of x in x by putting 5 into it. So by adding 5 to it, so it's just basically you can declare this x equal to x plus 5. That's how you update it. D, declare initialize it a double variable pay rate. Y is pay rate, a good variable name with it because it tells you what that is, because it's money. And you basically use a double for that one, okay, with the decimal. Because why? Why do we have different types of data type? Again, this goes back to the precision part of this. And I'm going to post a discussion board a little while. It's a little extra credit if anybody wants to participate. E, copy the variable of the first num of the int variable first num into the int variable temp num. Okay, so this is kind of like a swap copy with it as well. So you can do temp num equal to first num. That's how you can start. What I normally do is write the right hand side equals the left hand side, but anyway. F asks you to basically swap the content. This is the swap though. You got to have a third, what I call is a third memory to do this. So declare additional variables as necessary. So you do have int x, y. I'm just going to we can call this temp, okay? Like a memory, like a spare tire, you can pull things to it. So one of the first thing I do is I declare temp as a variable with it. I take temp. I want to take temp, I want to put x into temp. And then I'm going to use the x equal to y. I want to actually do that little swap, and then I'm going to do the y now equals the temp. So I basically use the temp that's aligning, let me get this to be easier to align with it. So this is what the typical swap algorithm is. This is for sorting. We'll talk about this a little bit further. As you can see with this as well. FG, G asks you, suppose x and y are double variables. I'll put the contents x and y. Anytime when you output, you got to use your cout. What's the symbol called? Stream insertion operator. You're inserting content onto the output of the screen. It's the reference of the source code that you're writing it from. So you're going to output this to the variable. And a lot of you miss this, is that you got to have a space between your variables in here as well. So the next variable, you notice how I put variables. I didn't put quote. Anytime I put quotes, those are what's called literal. And they want you to put a little space between there. And inside of this, it tells you to actually, they want you to x plus 12 and y, and you divide by that. So here's what I'm going to do. I would normally use parentheses with this. So you can do this, divide by, put some parentheses, y minus 18, close up that parentheses, and always have an NL. I take an N with a semicolon. So this kind of wraps it up with it, moves on to the next line with it. Next one says declare the variable grade as a variable and set the value grade to a character with it. So here's H. You can do char, okay, and grade, and equal apostrophe A. I was on semicolon. I declare int variable stores for. This is just an int variable. You can do this. Maybe just store 4 variables. There you go. Num1, num2, num3. I don't care. So J, copy the variable. Now a lot of you missed this one. Let me explain this. Copy the value of a double variable z to the nearest integer. This relates with the first program exercise where you run off to the nearest integer, where I show you how to do a 0.5. Remember that? And then you take the integer part of it. A little tricky here. Okay, so one of the things is that you got to store all of this into x. So why don't we write this from right side to the left side? Okay, so I'm going to put equal. I'm going to use the static cast command, and then I'm going to, inside of this, I'm going to convert it into an int data type. From the int data type, I'm going to use the z. I'm going to plus the 0.5, okay, semicolon, and all of this needs to be stored in where? Yes, in the x. Okay, so that all this is number 8. Okay, let me check on the time really quick here on this one.